Hello everyone and welcome back to another video. It's been a while. College has been doing college things, which has kept me pretty busy, but I do have a few things to show, mostly in relation to Godot, so let's get right into it. Firstly, I wanted to talk about the SMuL framework I invented. SMuL stands for Simple Multiplayer Using Leaderboards, and it's been an idea that I've had for almost a decade now that I just haven't been able to make due to not having enough time or experience. Thankfully, one of my classes tasked me with creating a digital mechanic, which gave me the perfect tax write-off-ish excuse to make this prototype. The idea behind the SMuL framework is pretty simple. Since I'm already familiar with LootLocker from using it to make Pompoka 3D's online leaderboard, I wanted to convert it into a makeshift backend server. The way I can do this is by treating scores as player states. For instance, if I roll a 6 in my game, my score on the leaderboard also becomes 6. Then anyone else playing the game can check the leaderboard and simulate me rolling a 6 in their own game. Obviously, it is more complicated than that, but that's the basic idea behind the framework. If you want to try out the demo yourself, I have a playable version on itch.io, and if you want to try using it in your own games, my code is on GitHub. I will say, however, to not abuse LootLocker. The simple and SMuL not only represents that I want the framework to be easy to use, but also that it should be used for games that don't have a lot of interaction, like board games where the players take turns, and not something like a platformer that requires constant connection and communication. Currently, I think I'm happy with the SMuL demo for now. It is currently in a minimum viable product state, meaning it works, but it has some problems and bugs. When I start using the framework in future projects, I expect to refine it, but that won't be for a while. The next project I want to talk about is a small thing I did for another class last semester, that being a dice simulator. This was actually the first project I finished in Godot, however, because I put my results in the debug window, I only have it available through my code on GitHub. The idea behind this project was pretty simple. Loaded dice are dice that are unfairly weighted to manipulate their odds. Similarly, the odds might not be fair if the geometry of a die is not even. Due to this phenomena, I wanted to see if there was a relationship between the dimensions of a die and its fairness. In order to do this, I designed 5 types of dice that would have their dimensions manipulated, including a tetrahedron dice that would have its height change, a cone die that would also have its height change, a frustum coin that would have one of its radii change, a bicone coin that would have one of its cones' heights change, and a standard cubic die that would also have its height change. I ended up running each die at 25 values of unevenness, and for each measurement, I rolled the die 10,000 times. This meant that the simulation ran over 1,000,000 dice rolls, which was not the fastest process. Nevertheless, these are the results I came to. Some things that I noted were that the green side was rolled less often for shorter tetrahedron dice, despite being identical to the red and yellow sides. I also noted that the frustum coin was fair, however the greater the imbalance between the top and bottom radii, the longer the coin would spin. Originally, this triggered a failsafe I had for bugged dice while the coin was still spinning, meaning my data for the first simulation had to be thrown out, and I had to redo the simulation with a longer window before my failsafe kicked in, which did fix the issue, and it also told me that the bicone dice also suffered from the issue in my first set. Lastly, for some reason the shorter cubic dice got stuck in the ground a lot. From these issues, I think it might make more sense to run this test in a better simulator than Godot, but I'm happy with what I was able to produce. While I did give a presentation on this project, I originally planned on making a video on it, so talking about it now means that idea finally kinda came to fruition. The last project I want to talk about is Tethered, Skeletower, and Skeletower. I've had several streams on Skeletower, but I don't think I've made any straight up videos on it, so I'll give a breakdown on the history of the project in my future plans. I originally came up with the idea for Tethered years ago, even before something like Pompoka 3D. The idea was going to be climbing a mountain with 2 characters who could tether themselves to each other in order to fly around like a controllable version of the bubble from New Super Mario Bros. U. My main problems with the project were that the characters weren't fun to control, being clunky and slow, I wasn't experienced with programming then, and my biggest problem was that I didn't have a story. I had a setting with the mountain, and ideas with levels, but I had no motives for the characters to climb the mountain. This idea evolved into Skeletower, which also features 2 characters with similar abilities, but it fixed a lot of the problems. First of all, I now had experience with programming and modeling, meaning I had the ability to do this. Secondly, I changed the mechanics to make them more fun and fluid. That being, instead of tethering the characters together, you could sacrifice one skeleton and they would surround the other, and then when you want, the skeleton could reform out of the swirling vortex of bones and bone bash. This move can be used to get additional distance and height, but also speed, as when you hit a wall with the bone bash, instead of just hitting it and bonking, you actually ricochet back into the skeleton that you were originally controlling, and you get sent backwards at high speed, which can be used in the player's favor if used correctly. I still want to go through with this game, but I originally started making the game in Unity, which decided to introduce a runtime fee, and while Unity has since removed their runtime fee, I just don't trust those greedy son of a Goombas. This is why I decided to switch to Godot in the first place. While Godot is very similar in a lot of ways to Unity, there are several notable differences. This meant I couldn't straight up port the game from Unity to Godot, especially since I still had no experience of Godot at the time. As such, I decided to make a simple spin-off of Skeletower called Skeletower to learn Godot. As for what Skeletower is, it's a pretty simple bullet hell based off of skeletons from Skeletower, where your goal is to make your way to the top of a shower while avoiding and fighting various toiletry enemies. As for my current progress, I have designed and completed the 3 main enemies that appear in the level as well as the player mechanics. The only major thing left is to complete the boss of level 1, the biblically accurate Soap, who I've already mostly modeled and animated. I just need to create his AI. If you want to stay up to date with my development progress, I post a lot of it over on my Discord server, so feel free to check out some of my work there. Alternatively, I plan on posting some videos on Skeletower when it's done, and I plan on streaming my complete creation process for Skeletower, so if you want to see that, you should subscribe. Wink wink, nudge nudge, appease the algorithm. But with that, I would like to say thank you all so much for watching, and I will see you guys next time. Goodbye.